that, I am proud to get out of your way and hand everything over to Dan. I don't, Dan, you've been preparing for this talk for like a month plus now, and it's I'm super looking forward to it. With that, I will leave it to you. Take it away, Dan.
Thanks, Brooks, and thank you very much for hosting me and for everyone here for joining tonight. So a little bit about me. My name's Dan Shields, and I'm here in the Denver area, and I'm a big fan of all things blockchain and cryptocurrency. So like my claim to fame in the local area is I run Cryptorado. This is a community of people who all are around and like to do this kind of stuff, use it, interact with it. You might recognize a little symbol behind me. Ethereum is something that I've come from in the past few years. But what has really kind of piqued my interest and what I've spent a lot of time on recently is this thing called Substrate, which we'll talk about tonight. And this is a framework for building blockchains, specifically in Rust. So that's why we're here tonight. And well, heck, I guess we'll get right into it and I'll show it off to y'all. But to give you some semblance, like the community that's here is primarily interested in building applications, decentralized applications. They're called dApps. And Parity is building the Substrate framework that goes a step back and says, maybe instead of just building applications for these distributed networks, how do we build different independent networks and go from there? Because I think the problem space is still something really interesting to be looking into. So I think I posted it in the Zoom chat, and I'll post it once more. These is a link to my slides. And if anybody's watching on Zoom, I'm sure Brooks will cue it back up. And let's see, hopefully you all see what I see. And if you do, we can get started. Thumbs up from somebody? Looking good?
I can see it.
Cool.
Yes.
All right. So let's get right into it. So blockchains, I think I did a quick survey of the room a little bit back, but I would be curious of those who feel comfortable, they kind of understand what blockchains are, what they do. I don't know if we can give me a thumbs up or thumbs down, kind of shaky, and maybe let me know in the chat. And please do let me know in the chat if you have any questions. Queue it up, anything along the way. So assuming that you've heard of these things before, let's talk just a little bit about like what makes a blockchain. So a blockchain in particular, right, when we're talking about more than just a data store for blocks, is a network. And this network is generally consistent of nodes. So independent peers who all store the same database and all come to consensus around what data is in there and making sure that it's immutable and for all of time. And it also comes around, as we'll see here, most importantly, the state transition function. How do we go from one state in this database to the next? And really that's effectively adding a block. How do you go from one block to the next in this chain of blocks? So all of this stuff is included, right? We need a database of some kind, a peer-to-peer network and a layer for all of these nodes to communicate with each other, a way to author blocks across the network. And then if there is some fork in the sense of we have some conflict in which version of the next iteration of the state is coming, we need to be able to decide which one's the correct one. And then transaction handling. So blockchains, at least principally now, are used for cryptocurrencies, right? And so that's the kind of claim to fame for a lot of people. And really what we'll focus on is this runtime. In particular, Parity is this company, which actually I'm pretty stoked. I'm signing on today as an engineer to support anybody who's interested in using this tech. And they've developed a lot of different blockchains over the years. So we were discussing this earlier. Open Ethereum is out there. It used to be Parity Ethereum. It's a client for the Ethereum blockchain. And they've also built Bitcoin, I believe Zcash, and maybe one or two other clients. And in particular, the thing that they're focused on pretty heavily right now is Polkadot. And we'll get into why Polkadot now is the thing that they're after. But in building Polkadot and with all of this previous experience in building other blockchains, they've come to bring Substrate. And Substrate, what is it? This is a framework specifically to build blockchains, right? So it's open source, it's modular, and it's extensible. You can think of it like other Rust-based frameworks that are out there for web dev right now, but specific to the blockchain industry here. So this is what they give you. And we'll go over specifically what does it provide. It, out of the box, will give you a database layer, networking, this transaction queue if you're doing something like a cryptocurrency, or if you're trying to build the next state in a block, and a consensus engine. And you can choose, you can plug and play which ones you'd like. And then the thing that I really want to focus on today is this library of runtime modules. So what your blockchain actually does, how does it process things more than just naive transactions? What can we do with the runtime itself when we go from one block to the next? So to get it in context, a lot of the blockchains that are around have built all of these things from scratch, right? So this database layer, how you do networking and transaction queue and consensus, if you're going to build a blockchain, these are all the things you need to build a la carte, or fork from somebody else's project and try and patchwork it together into something that works for you. So Substrate is trying to address that problem and let anyone build a blockchain that is highly compliant with what the things you need, and mostly abstracts away the stuff that you don't need to think about and how the blockchain operates, and lets you focus on the core of what the blockchain is supposed to be good at. This library of runtime modules is really what enables you to do this. And of course, all of these can be customized and extended. And I'd say the interface to each is pretty clean. So it really helps you plug and play what you need. And of course, this is why we're here tonight. Substrate is built using Rust and Wasm. And we can get into some of the technicals of why that's cool if you guys want to. But of course, Rust is awesome. So to give you a sense of what does one of these nodes on this peer-to-peer network look like in a Substrate blockchain, right? Specifically, we have written in Rust, and this is compiled and built down into native on whatever machine you're using here. We have this networking layer. This is libp2p, so this is how all the nodes connect to each other. We also have out of the box adjacent our remote procedure call layer. So this is how we communicate from the web out to your particular node. And then we have block storage and transaction pool stuff that's all built into the node and you don't need to worry too much about, as well as a pluggable consensus mechanism. So we can get more into that again if you guys are interested as to how you change that up. But the real interesting part, I think, that we can focus on tonight is this runtime. So this is the application logic that really makes whatever your blockchain is supposed to do like special, right? So this is built in Rust and it's built into Wasm. And it also is at the same time built into native here. But the interesting part about building this thing into Wasm is that this blockchain's runtime is actually all assembled into Wasm, and you interprets it directly from that. So there's a Wasm interpreter that's built into your node, and the special sauce of the runtime is actually built in this. So it's easy to port things into the web and to interface with it because of this. So it's some special stuff you can do with it we can get into in a minute. So let's take a look at this runtime. This is the really exciting part in my mind, right? The pluggable architecture here that Substrate provides, it is whatever you think you need to assemble this next state, right, in your blockchain. So how do you make the next block? And typically, you can think of these as a palette of things that you want. In particular, so this is what they're called in the framework, as palettes. So you can compose the exact functionality that you want your blockchain to have, keeping in mind that there's some constraints around how much time you want each block to run and what's the bloat effectively that you're expecting a node to be able to do. So setting some boundaries on how much computer power, for instance, one of these nodes might need to run. So with that, I kind of want to jump right into some hands-on. So if you guys are following along on the slides, all these are active links you can check out. And I want to show you a little bit about some of these frame palettes. So first and foremost, Substrate, github.com, Parity text, Substrate. This is the actual framework itself. And out of here, I want to point out a few things if you guys are looking into this. This frame file in particular is where all of these palettes are going to live. So specifically tonight, we're going to look under frames nix and source libstart.rs. And this in particular is one of the palettes that we're going to add to basically a plain vanilla node. So if you're checking this out, under the frame palettes, you'll find the Nix palette if you dig around just a little bit. And then we're going to be looking at this Nix palette tutorial. So this is how you actually go from this bare metal node and add your own palette. So let's see, I believe, I'm looking for the tutorial. Maybe I lost it. Here we are. So if you guys are following along, this substrate.dev, the docs in the tutorials section, the Nix palette is what we'll be doing, add a palette. And before we get into actually putting this onto a node, I would like to show you what this node looks like. So this node template, it'll suggest that you pull this thing down. So you can use this as a template, pull it to your fork it, or I believe there's a method in which you can use it as a template and create a fresh copy of this. But so this Substrate node template is effectively the core of what everyone is using to build their own blockchain from. And in here, they've made some pretty safe assumptions about the base things that you would want plugged into here, about how do you do consensus amongst nodes and some of the base primitives. For instance, if we're talking about a cryptocurrency, the balances palette, which I'll show you here in a moment, is taking account of who owns what currency on the system, as well as accounts on the system in terms of how you do key management across this. So let's look back at this tutorial here. So if you guys want to check out the Substrate node template here, the core things when you're operating with this and you're just getting started up are really going to live in this runtime directory, and then specifically lib.rs within the runtime. This is where we're going to specify what plug and play palettes we would like, and a little bit of the cargo in there. So if you guys check out back on this introduction here, I won't go through the entire bit here with you, but I want to point out some of the key features on what you're doing. So to give you a sense of how this ends up being constructed, right? This runtime will specify specifically a whole bunch of basically overhead in terms of getting the core components that are included in this framework. So this is a lot of redundancy, unfortunately, but this is copy paste for all of these guys and pulling down which particular functionality we want out of the framework. But in this node template here, we're specifying things like, okay, what is the runtime called, and how is it, what's the versioning within your blockchain system here? So one thing I would like to point out that's kind of an interesting feature of substrate-based blockchains is this runtime is something that we don't necessarily need to fork, do a hard fork if you guys are familiar with the lingo. You can do a soft fork that occurs on chain. So you can update your runtime just by updating this file here, recompiling, and uploading the WASM file that's created to the blockchain that's actively running, and all nodes across the network will come to consensus on this is the new runtime and start using it. So we can get into more how that works later on if you guys are interested, but effectively specifying that goes on here. And then From there, what we'll see a lot of as you're moving through and understanding this is these macros. So specifically, these macros are built in Substrate to help get rid of a whole bunch of the junk that you don't necessarily need to think about in terms of what's going on under the hood. So this auto assigns a whole bunch of traits and types to the things that you're using within this. So here, parameter types is giving a whole bunch of extra functionality to these otherwise pretty simple constant calls. Right? You're constructing things here. So the macros here are something that I'm still wrapping my head around as I'm getting into Substrate, but effectively they help box what the components you need to think about designing within your runtime and with, for instance, any of the palettes you're using. So here, this parameter types is important, as well as we get a little bit further on, yes, so this construct runtime macro. So we do a whole bunch of declarations and we're adding a bunch of palettes into our runtime. And then finally, we're arriving at constructing this. And here effectively is plug and play for which things you'd like included. So jumping back over to this importing a palette, it gives you a sense of, in cargo, effectively, we need to give some pointing to what parts of the Substrate framework we'd like to use, and then link them up primarily in those macros for your node to be able to interact with them. So under the tutorial here, I believe, we'll be able to add just a few lines. Specifically in cargo, you're just specifying that you want a particular palette, of which all of these are up on crates.io as well. So if you want to explore some of the documentation, that's available for you. And for the most part, as true to Rust, the docs first seems to be pretty good. The docs are a great place to explore a lot of these features. And then after you've imported this particular file from cargo, we need to add specific features from this. And one of the key things that we'll see over and over again using Substrate is that the standard library is generally avoided when we're trying to build this runtime, specifically because we're building down to WASM. So the no STD flag is something that we'll see throughout this, primarily because we don't want to have native runtime. We don't want to have to use some of the features that we would see on a native runtime build versus the WASM runtime build. So you put an extra flag in there for that. And then once we've got that plugged in to cargo, we configure then in the runtime specifically. Here we are here. Right here. The parameter types, so things that we would want to be using specifically for whatever your palette is, get implemented within the runtime there. And for NICs, well, to give you a sense of what NICs is, this is nicknames, effectively. So this is this palette enables your blockchain to use, based on a reservation fee, you to assign a particular public key a nickname, right? So this is all that this particular palette is able to do. So we're specifying here that we need some reservation fee on whatever the base unit is here of your currency, and then some maximum length for that nickname, whatever it can be, or min and max length for these nicknames. And then specifically what we're specifying here is what kind of currency, right, out of the ones that might exist on your network that you'd like to be using for this. And then here we specify what that fee might be. And slashed, this is a concept here in the sense that we've got some reservation fee. If something goes wrong, or if we're doing something malicious or something along these lines, slashed is generally what happens. So when we slash that, what we're saying is the reservation fee needs to be, in this case, no action is taken. So that those funds, if they're locked up with this thing, are forever gone. But this is all configurable here. And then next we're saying the origin. So effectively, whoever is making a call to this particular palette, this needs to be coming from root. So as we'll see in terms of, as there's a note here, when we're doing development work, a lot of this can be facilitated through a master key that controls all accounts, effectively, is what we're specifying here, as opposed to what you would want to do out in the wild is there is no master root account. There is only individuals who have control over what's going on here. And then specifying the min-max length for that nickname, and then all palettes have an event type. So this is ubiquitous across all of the different palettes that you'll see. This is simply how you emit things from the actual node itself out for the world to see. So once that's added, we'll add one more line, and this is specifically in that construct runtime macro. And this does, under the covers, a whole bunch of linking up of this new palette within the rest of the runtime palettes that are out there. So to give you a sense now, back in this runtime, I have actually not added Nick's palette directly, but I have compiled, this is the raw template. So as an exercise, we can go through and we can add all this stuff for you, but I think instead, what I'd like to do is show you what running this node is. So if anybody, just to give you a sense, is building this, there's, instead of cargo, right now there's an unfortunate issue with the nightly builds on this that aren't functioning. So we rely on some of the packages that are in the nightly compiler. But so this WASM toolchain specifically needs to be predated before the 5th of October. So instead, we've got a make file that can help you out real quick and basically get around this. Hopefully this will go away soon. We just do cargo build, cargo run, all this stuff. But it will take you probably on a reasonable machine 20 or 30 minutes or so to build from scratch all these libraries, to give you a sense, because just updating it along with playing Zoom took me about 6 minutes to build this guy. But let's run it. So I do a build release here, and release, and I want to run the node template, and I want to run it in dev mode. So you'll see some of the information that's being displayed by this node as it's coming online is effectively who it is, what's going on in terms of its development state, where the database lives, and initializing, okay, we've got a Genesis block, meaning that we've started this thing from scratch. There's no pre-existing state, so we know how to initialize. And then specifically, some of the more interesting pieces is we know that Prometheus is now running. So this is the telemetry that's natively built into all Substrate nodes. And this RPC connections can be now available here at this port. So we're opening it up to be able to interact with this guy. And as you can see, as we're moving along here, I believe the default is every 6 seconds, we're producing a new block. So that's what we're seeing is block by block. My lone dev node is making its own blocks so that we can play with it. Now that this node is up and online, the next bit that we can do is on polkadot.js.org. This is the most established way to interact with Substrate-based chains, and the most established of them right now is Polkadot. So hence the name. So if you go to polkadot.js.org/apps, this will pull up an interface that you can interact with any of the many blockchains, at least the ones that they have listed, that are available through this interface. So you can see the live networks. There's plenty, of which the most well-known might be Polkadot and its little cousin Kusama, which we can talk about a little bit later if you want. But then, as you can see, it's already picked up. I've got a local node, development node, that's on the same port that we just saw in the terminal here that's running. And you can see blocks are being created, and we can look at things like the block deals that are going on. For instance, that, okay, we actually created the time, which is the mandatory event that happens at each block, right? These dev nodes, to give you a sense, if you guys haven't played in cryptocurrency much, all accounts are based on public-private key cryptography. So each one of these guys, specifically, let's see if I can show you the, one moment. It should be able to show you the public key, but I can assure you each one of these is associated with a public key, of which the dev node is loaded up, and this is because it's a development node. These are all publicly exposed, well-known keys, some of which are given some cryptocurrency on our little dev unit. So for instance, now that it's up and running, right, let me go ahead and show you here on the Network Explorer, get this guy queued up. When I send some funds from Alice over to Bob, the amount of a bunch of money, a bunch of fake money, fake and magic internet money. So I sign and submit a transaction. We should see within that 6-second block time that apparently things failed. Insufficient balance. So actually, I apologize. That was too many magic internet monies. Let's send one more, the amount of 10 internet magic monies. And this should end up working out, as opposed to sending too much for me to get it to Bob. But effectively, what we're showing here is that proof in the pudding, yes. As a matter of fact, I did send some money from me over to Bob. The node actually did end up picking that up. So we can see blocks are being processed. And specifically over here in the Explorer, we're able to see a recent event, the things that we were mentioning that all palettes have, that yes, indeed a balance transfer happened. So here, as you guys are getting more into the development side, as opposed to just sending funds around, because that's, you know, the naive thing, right? That's the thing that all blockchains, at least cryptocurrency-based ones, they must do to be functional. But beyond just sending money around, what can you do? So in the developer interface, specifically under extrinsics. So extrinsics effectively identifying that we are making a call from outside the network into the network, right? So we're submitting something, specifically in this case through the JSON RPC to one of the nodes to process something, right? To give you a sense, this basic node template only has a few palettes. So each one of these is specifically a palette that's incorporated into our accounts. So for instance, sudo, right? This is this root key that can overwrite whatever it might be. You can do things like set a new key, and you can perform an action as sudo, right? Similar to what you might expect. So for instance, if I'd like to, I could do sudo as who, right? And for balances here, I could transfer from Bob, right, over to Alice, right? Running as Alice is the sudo key. So something along those lines. What I'd like to illustrate here, though, is that you've got this really pretty nice GUI right out of the box to be able to interact with custom logic that you're putting on chain. So all of this actually gets auto-populated if you incorporate your palette and use those fancy macros to do your construct runtime appropriately. So if you're developing your own palette to plug into this node template, it will very easily and simply connect into this. So this polkadot.js.org is a great way to check out. Another way to interact with this guy is specifically through this front-end template. So this is what you'll see in a lot of the tutorials that are available out there as well. And this is effectively a simpler version of the overall polkadot.js app. As a matter of fact, I think I can show you that as well. So, and this is a React-based tool set. So you've got some pluggable components right there to play around and interact with your node right out of the box as well. Here we are. So here what we can see is some more developer-specific information that you might want to check out. Information about the block, it's updating per block, as well as more direct interaction with the different palettes that are there. Sweet. So to give you a sense, I believe this is linked in the slides as well. This is the solution. Specifically, I think you'll find it right here, this branch with mixed palettes added. this is all you'll need to do to add an established palette that's out there in the wild, right? So we're adding in cargo, just these two little bits here, actually importing it and then specifying the standard flag. And then this parameter types, so defining what the interface is going to be now inside of a runtime, specifically which parts do we want. And then lastly, putting it inside of this construct runtime macro to make sure everything gets linked up appropriately. So if you guys want to, we could go ahead and plug this guy in. We can see it auto-populate, but I'd also be well open to any questions you guys have, because I know I've gone kind of wild and fast on this and not very deep. So I'd be curious about what things you guys are interested in knowing more about. Cool. I can check out in the slides or I can listen.
So what's on my mind is, currently who's used Substrate, created products from these frames. So I don't know too much about it. What kind of examples are out there? Big real world.
Yeah. So right now, and maybe this is something that I can jump into if everyone's interested, blockchains a la carte that are independent from each other, those, they're great, right? But the idea of having interoperable, interlinking blockchains is something that I think everyone's trying to aspire to. And Substrate makes it very easy and has pluggable interfaces to communicate with any other Substrate-based blockchain very easily. So in the ecosystem that you'll see is Polkadot in particular wants to hyper optimize its blockchain to be a relayer. So its job is to connect other blockchains to other blockchains and be a message passing system, as well as a security system for, if you'd like, to rely on that as effectively your base of trust. So the people who are building blockchains with Substrate right now mostly are interested in that relayer and security layer that Polkadot is providing, and they're called parachains. So actually, I might bring my slides back up again, if I can. So let's check out. Yeah, here we go. This is kind of the broad idea I think Polkadot is really trying to go after with making Substrate this easy to use framework, is to bootstrap a network of different blockchains, each of which is really optimized for a specific purpose. So like in my mind, the way to think about what these parachain networks would look like is similar to multiple devices that you have at your, for instance, in your home network, right? Is each one of these is for a very specific purpose, right? Your NAS is not going to do the same stuff as your smartphone, right? So a blockchain that's catered to a very specific thing, for instance, like Filecoin, people might have heard of for storage, and for dApps like Ethereum, those two things interlinking and communicating much more clearly is something that Polkadot really wants to enable. So that's what people are thinking about using. And in particular, these parachains, I can think of right now, the hot thing, especially because of the environment, is Ethereum compatible smart contracting platforms. So that, as well as bridges to actually Ethereum. So the parachains that I know are most promising, people are most excited about right now are, oh gosh, it's, I gotta remember. There's two or three. I can post these in the chat and link up to everyone later about these, mostly Ethereum interoperability. But people are thinking about other things for sure. About, so this is really what people are using to enable this Cumulus framework that's available, that's built on top of Substrate. So another one of these templated nodes effectively is a Cumulus template that we can take a peek at if you'd like. These guys are specifically made to plug into Polkadot and communicate with other Cumulus-based Substrate blockchains. And here they're primarily putting the onus of security on Polkadot for making sure that nobody's rewriting the chain or going too far back in the block space that's there. So that's kind of the architecture people are thinking about, is a relay chain that's hyper optimized just for that, with other blockchains that do a very specific task that all link into it, potentially other relays that are hooked off of it. So I don't know if that answered your question. Is that good, Adam?
We have another question, which is from chat. Is it trustless?
Is it trustless? So I would want some refinement on what would you not be trusting? And I would say in general, these guys have a consensus engine in which we are building on proof of stake. Nominated proof of stake in particular is what Polkadot is using. And out of the box, that's what all of the Substrate nodes consensus mechanism is being plugged into. So trustless in the sense that you are trusting the consensus mechanism is valid, and we can definitely debate about if proof of stake is a valid way to go about this. But for me, I think it's definitely a pretty valid way to go about it. In particular, Polkadot, as we talked about in these developer-based nodes that are here, will have a root key, a pseudo key. In Polkadot, it was launched with one that has now migrated into a governance palette. So there is no one ruler on the Polkadot network. There's on-chain governance that I'm not sure of the exact mechanisms. This is something I'm learning about now. But you have to come to a social consensus under this for anything to go about using this root key or do things like runtime upgrades. So if you trust a large set of people who are vested and staked, quite literally have skin in the game, that this is working right, then yes, it's trustless.
All right. So as follow up to that question, it was like, how do we avoid the problems with Bitcoin, Ethereum, Lightning, ZK rollups are only temporary solutions? I guess I mean decentralization, no single point of failure like ASICs, whales.
Yeah. So I guess there can be a lot of problems between Bitcoin and Ethereum, and in the sense that proof of work, if you guys are familiar with consensus algorithms, right, is a very costly thing. And there's definitely some pros and cons to it, something we could talk about more philosophically. But centralization in terms of the mining there, so how much control over the whole network does some small group of miners have? In Bitcoin, Ethereum, and proof of work we can debate about it, but there's definitely a few large pools, large players. In here, the proof of stake, you will see some of the same dynamics in the sense that there will be large pools that are there. But for the most part, I would say that the tokenomics, so how they're trying to design the system, is focused to try and bring more distributed, more equitable operators of the nodes who are receiving rewards and mining the chain effectively, as well as having governance. So if you're curious about that, afterwards you can hit me up. I can get you some more specific documentation about that. So now I'm looking as a framework for building blockchains. Could you recreate the other major cryptocurrencies with Substrate? And follow up, are there any major blockchains that you could not be created with Substrate? So as I was mentioning in the beginning here, Parity has built a bunch of other blockchains, and it wasn't based on Substrate specifically, but they're all Rust, implemented in Rust. So for instance, Zcash, Bitcoin, and Ethereum are ones that I can know off the top of my head that are implemented by the same team. And there is a tutorial that I can pull up for somebody if you're interested about building not Bitcoin itself, but the Bitcoin's state mechanism, the state transition function. So having these UTXOs, universal transaction outputs. You can build a blockchain on Substrate that uses this. So it mimics what Bitcoin is all about, whereas the default is state-based, it's account-based. That doesn't use UTXOs. So you can build kind of any blockchain that you'd like. If there's any that you could not, I'd say that Substrate has some strong, I guess, coupling, maybe is the right word. It implies that the right way to do things is public blockchains primarily, and how you do networking and things like this. It's pretty dependent on this libp2p framework. So if you really wanted to basically get rid of all of this easy modular framework stuff, then yes, you could use Substrate and pull way back across down basically to the roots. But for the most part, it's going along with their defaults is a pretty good assumption there. I'm looking if there was a way to back or at least tie the Polkadot currencies to cash. But what is cash, reputation, karma, natural currency? So I think this is more of a philosophical question about is magic internet money actually worth something? Or can you tie it to cash? I think that's up to you to decide. I'm not your financial investor, and not an advisor for sure. But is there a way to directly link to cash? I know that stablecoins and stablecoins that are backed by assets like cash are definitely something that are being played around on with parachains. So Polkadot in particular doesn't have native integrations except to be highly optimized about this relayer function. So it only does currency to manage the accounts of making sure that everyone's playing by the rules and to process fees for making sure this message passing and security goes well. So we'll see. Some of the parachains will almost assuredly get more into this world. Acala, A-C-L-A-L-A, I believe, is one of the ones that's working primarily with decentralized financial tools right now. So that's the premier one that people are talking about that you might see some of this stuff on. Cool. Well, I'm wondering if anyone has any other follow-up questions. And if not, totally fine. I would love to get some feedback from y'all because I know that in general, I'd like to take this presentation, make it better, make it more useful for people as I'm moving forward. So let me share my screen one more time. Here we go. So I would ask anybody who does have some feedback or would like to know more in general, come find me. I am generally accessible everywhere as New Command Dan. You can also find me now at Parity.io. I just signed my contracts today. Dan.shields@Parity.io. And Cryptorado is the other thing I wanted to highlight for you guys. If you're interested in anything to do with cryptocurrency or blockchains, we do bi-weekly meetups, and we've got an online Discord chat, and you can come and join us there. And it's been quiet for a while, but I'd really like to do some free and open source software development, specifically around using Substrate as means to an end. So this Cryptorado node project in particular is something I've been dreaming about for a while. If you guys are interested in some of what that might be, come and find me. But the idea of effectively a crowdsourced cloud for a small trusted community is what I'd really like to see us build for ourselves. It might be useful for other people. So come and join us, Cryptorado. And otherwise, I think that's all I got.
Hey, Dan, I basically slept through your whole thing, but I just wanted to pop in and say congrats on getting the new job. And it's cool diving in the rust. So,
Cool. Thanks, man. I'm glad you're able to come. Thank you very much.
yeah, for sure.
Thanks, Dan.
For sure. So I might throw one more thing in the chat here for you guys. If you want a much more broad overview of some of the stuff that's happening at the front lines of Substrate in general, some of the cool features that people are working on, there's this talk on Crowdcast. This is part of a large event. It was Sub-Zero, and I'll post a link for that as well, that Parity put on. And this, I believe, happened about 2 months ago. And really great tutorials, really great overview of some of the tools that are coming and some of those projects that we were talking about, some of the things the parachains are building right now. It's all there. But this one that I linked is the keynote with Gavin Wood, who's kind of the figurehead here, who's put all this together, really concise about specifically some of the cool stuff that's up and coming for it. So good place to start for sure. And of course, there is an unbelievable amount of great places to learn on substrate.dev. So if you explore around on that site, there's tutorials. There's also a whole bunch of forkable examples that are in the recipes. And every Tuesday, there's a live event that goes on, I believe it's 8 a.m. our time and Mountain Time. And this goes over bleeding edge, what's going on in the community, and teaches you something. So this seminar is a great place to get something that's more eclectic, maybe, and put together here for you all to check out.
Oh, hey, one more question, Dan. Are you so you fully switched over to the Discord instead of the Keybase for CryptoRado?
Yeah, so the group, for those who aren't involved yet, we use Keybase, which is a great tool. If you haven't seen it, I'll drop it in the chat. Specifically because in the cryptocurrency world, frauds and scams and impersonators and all this stuff, they're everywhere. And Keybase can help protect against this in a lot of ways. But Discord, yeah, primarily for the public-facing stuff is where we're at presently right now. So Chit Chat will be on Discord, but Keybase is still a strong thing that I want to keep in our community as a tool to make sure that we can help fight against that stuff.
Sounds good.
All right. Well, you're all welcome to continue hanging out on this this Zoom. It is a paid Zoom, so we have as long as you would like. But I am basically ready to call it a successful last meetup of the year. Does anybody else have any announcements that you'd like to make? All right. Well, with that, let's have a great rest of the year. Stay safe, stay warm, and we'll see you next time.
Sounds good. Looking forward to the next one. Thank you all.
All right. Bye, everyone.